Hello everybody, inshallah our case study about the greenhouse farm in Al-Batina. Nextly, what we know about this case study, the location will be in the Al-Batina and the major crop is a cucumber, and the textural class and the soil texture category will explain in the next slides. The three main indicators will focus on chemical and biological and physical. Okay, here you can see the texture triangle to find the soil texture, and we find the sand is at 15, go at 15 here and go up, and after that the size is at 20, go here the side and go down, and after that the clay is at 30%, so at 30% it is here and go down, the result will be sandy clay loams. Here you can see the color of each indicator that represent the score rating, and I will explain one example which as in available water capacity in the next slide. Here you can see the score curve to indicate the color. So the texture of the soil is a medium, it's the dash line. For the available water capacity, go to 0.15 here and go up and go to 45, and that the result will be the yellow color. We start with the physical, which is available water capacity. The scoring grade is becoming in yellow color, which is a medium level. But the medium level, it's a very good situation, but also need many improvement. We have many solutions in short term and long term. The short term, we add stable organic material, and also we add compost and incorporate high biomass cover crops. While the long term, we reduce the tillage. Reducing the tillage means we increase the runoff, and we reduce the infiltration. Also, we rotate with sowed crops, extensive rhizomes. The second physical is the surface hardness. Also here we have the yellow color, which is a medium level. We need a little bit of improvement. We have the short-term solution. We use the aerators to soil losing. Also, we use the shallow-rooted cover crops to reduce the compaction, and use the cover crops which is not harm to the cucumber. While the long-term solution, we avoid traffic on the wet soil. We use the shallow tillage. The shallow tillage reduce the compaction. And also the last thing use it's field traffic with wheels. This is mean we make a route for wheels to pass through. The third physical indicator, the subsurface hardness. This is a red color, which is means severe level. We have many solutions. The short-term solution, it's use the deep tillage to create cracks in the subsoil to reduce compaction. Also, we use plant deep-rooted cover. With, for example, we use the Kuwaiti trees because it has this is a very huge root. Also, they keep the debris such as rocks and bricks out of the topsoil to prevent the interface or change in the soil texture. The long-term solution is to avoid the heavy loads, reduce traffic, valid traffic with the wheel loads lower than the carrying capacity of the subsoil, and the last one is make specific pathway for traffic to reduce the compaction. The last physical indicator is the aggregate stability. This is in orange color, which is intermediate danger. We have many solutions. In the short-term solution, we use incorporate fresh organic material. We use a shallow-rooted cover rotation, crops such as grasses and legumes, and the last one we add manure, green manure, and mulch. The long-term solution, we reduce the tillage, we use surface mulch, and the last one we rotate the sod crops and mycorrhizal hosts. The biological indicator, we have first the organic matter. It is yellow color, which is a medium level. We need a little bit of improvement. The short-term solution, we add organic matter, reduce the drainage, grow green manure crops, and also incorporate high biomass cover crops. The long-term solution, we reduce tillage, rotate with sod crops, which is when die, it will add new organic matter. And the last one, keep cultivation to the minimum. The biological indicator also, we have the soil protein index. It is yellow color, the medium level, need a little bit also of improvement. The short-term solution, we add nitrogen-rich organic matter,
Inoculate legume seed with rhizobia. Rhizobia, it's a bacteria that fixes nitrogen. Inoculate to increase the legume nodulation and nitrogen fixation. Also, the long-term solution, we have to keep the pH at 6.2 to 6.5 to help nitrogen fixation and monitor the carbon to nitrogen ratio and to reduce tillage. The third biological indicator is the respiration. This is a green, very dark green color, which is a very good condition, no need for improvement. The biological indicator, we have the last one is an active carbon. It's a beer that is orange color in intermediate danger. We need a little bit also of improvement. The short-term solution, we add an organic matter like cover crop, manure, and mulch fertilizers, because the cucumber require a moderate amount. Also, we apply crop rotation farming and we use different grasses species on land. The long-term solution, we reduce tillage, we adopt appropriate grazing management strategies. Also, we try to plant perennial species. The third indicator is a chemical. We will first talk about the pH. The pH is a red color, which is a severe level. This is a very bad situation because the suitable pH to grow cucumber is acidic. So we have short-term solution and long-term solution. The short-term solution, we add many different plants. We add peat moss and coffee ground to lower the pH gradually, and we stop adding lime or wood ash, and we add aluminum sulfate to faster acting than the elemental sulfur because it is very soluble and safely. The long-term solution, we test the soil annually and we use a higher amount of ammonium and urea. The second thing in chemicals is phosphorus. It is a red color, which is a severe level, very bad situation because the cucumber need a high concentration of phosphorus. We have solution in short-term solution. We should maintain the pH. We should cover the crop with recycled fixed phosphorus, and we use residues taken from the buckwheat, green manure crops to reduce the excess phosphorus. And also we use clay because it has a very large surface area which absorbs phosphorus easily. And the long-term solution, we promote the mycorrhizal population, maintain the pH at 6, and use cover crops recycled with fixed phosphorus. The third chemical indicator is the potassium. This is a light green color, which is a very good situation and no need for improvement. The last chemical indicator is potential mineralizable nitrogen. It is a yellow color, which is a medium level, need improvement. The short-term solution, we add wood ash, fertilizer, manure or compost, and also we choose a high potassium fertilizer. The long-term solution, we use the biofumigant and crops, which is used as a green manure incorporated with the glucosinolate containing the GLS plant. So as you see here, we have a reference that we use it in our case study to find the solution.